Hello, today we're going to present to you our advanced software development project under the lecturer Dr. Eliyahu Haleschi. This is our team. We have 5 people. As a time management tool, we choose Monday. Monday allows us to oversee our development of the project over time. As we can see, we finished all of the things in time. We have a few pages here showing you the development of Monday. Around here, we can see the architecture rules of the front, which is MVVM. As we can see, we follow the model which Dr. Eliyahu instructed us to do. In here, we can see the MVC model of the backend. Okay, now we're going to review the features of our application. Here you can see the GUI made by the front end. We have a map that we can zoom in and zoom out of. We have all the graphs here waiting. Later, we're going to refresh the button and see the queries going to the backend and retrieving the data. And now let's try to connect the first agent using the jar files that we made. And as we can see, we have the first plane on the map waiting in standby. Now we're going to connect the second agent from another computer using the jar files again. And as we can see, we now have 2 planes on the map. Each of them is waiting in standby. And if we click one time, we can see the details about each plane. If we're going to refresh the button, we're going to send queries to the backend and get data about our fleet. And by double clicking a plane, we're going to go to the monitoring and then the operation. And we're going to start a flight. Let's see the plane moving. And the plane is starting to move according to the buttons in the teleoperation. You can see that we control the plane and it's reacting to us.
Okay, luckily we are engineers, not pilots.
And now let's go to connect the second agent and see it fly. And now we're going to choose the second plane and run the interpreter script. And we're going to send the script to the backend for interpretation. And we're going to see the plane is starting to move and fly according to the script. So right now we have 2 separate planes flying using the same interface. And now we're going to see the monitoring page. As we can see, we have 42 features on the left. We can choose each one of them and going to see the best correlated feature. And according to the threshold that we set, we can see the anomalies for those features. Right now we're seeing the linear regression. As we can see, all the dashboards are moving according to the plane's flight. You can see another form of anomaly right here of the hybrid algorithm that we used. And the plane is still flying according to the script.
Okay, so now we're going to show you the time capsule feature. So as you can see, we have the FlightGear with the instructions that we put to use FlightGear as a projector. And let's press fly. It will take a while for the FlightGear to load. And now we can load our GUI application. I'll hit the start button. And the GUI application is up. It will take a while for the GUI application to make the layer normal, analytics and statistics to get the correlated features and for us to be able to detect anomalies live. Okay, so FlightGear is up, as you can see, and we'll go to the time capsule tab. And now, as you can see, the time capsule, we have the features, we have the graphs for the feature and the correlated one, and we have also the graph for the anomaly detection. We have the flows of the plane, and we have the joystick with the sliders. So let's hit open, and we choose the regfly.csv file, and the file is loaded. And now we can hit the play button. Okay, so as you can see, the clocks are initializing. We'll see already the joystick moving, the sliders moving, and we can take a look at the FlightGear simulator. As you can see, it's going to start flight. And it's on. Of course, everything is going from the CSV file. Okay, so if you look at the engine, you can see that the engine is using the linear regression. That's because we have a very high correlated feature. We use a hybrid algorithm, and if the correlation is very high, so we use a linear regression. And now we can take a look at the vertical speed indicator. Okay, so as you can see, we have the vertical speed indicator. The vertical speed indicator don't have a very correlated feature, so we use a z-score model. As you can see, the feature and the correlated one is not so correlated. They're very different. And if you hit the pause button, we can see the simulator is paused, and we'll hit the play button again, and we can see the flight keep moving, and we can increase the play speed to 1.5. Now it's a bit faster, and let's hit speed of 2, and it's really, really fast. Go back to 1, and I think we're done here. Thank you very much for watching.